Everyone. My name is Nicholas. I work for Canonical. I am the VP of Field Engineering at Canonical, which is the team that focuses on professional services and pre-sales. And I'm here to talk to you about operators and containers and how migrating your applications to uh, a cloud native environment is quite a challenging thing, but certainly something that can be implemented in a very, very good way. I'm going to try and share my screen. Uh, if you allow me 1 second. Um, okay, share screen. Okay, so the importance of using operators when migrating mission critical business processes to microservices architectures in an enterprise environment. It's a very long title, but essentially this means that we are trying to help customers migrate their applications to much more of a cloud native and microservices type environment. But of course, this comes with challenges because everybody is essentially trying to migrate their apps to the clouds. And when I say clouds, of course, I mean public clouds, private clouds, generally infrastructure that feels cloud-like, very much self-service, very much microservice oriented, auto-scaling, container oriented, and so on. The problem is that applications in general, the way that they have been built, are an absolute mess. Um, and if you have been working in the application space, you know exactly what that feels like. Um, this essentially is your app. It's a uh, it's a big set of services, a big set of code that has been built over the years. It runs on typically some private infrastructure, most likely in some virtualized environment, and essentially the aim is for this to become much more cloud native, much more um, uh, flexible, much more scalable, and most likely focused on latest technologies like containers. Um, and most likely, what it looks like is a number of potentially open source applications, some databases, some front ends, some messaging buses, some sort of uh, visualization tools, and of course, your own proprietary code. So the code that you essentially write that brings this application together and utilizes all these different components. Of course, the biggest challenge with that is that, as I mentioned before, this is a bunch of virtual machines that are running on virtual environments. And it is, of course, quite challenging uh, to basically say, I'm going to take this and deploy it in a cloud environment, be that an OpenStack environment or a public cloud environment, because just moving VMs from one place to another doesn't really get you that benefit that you're looking for in order to optimize your software operations and optimize essentially your costs, right? So the question is, what does a clean cloud native application look like? First of all, the big trend, as you probably already have heard and know, is to use prepackaged containers. So you take all those different components that we were mentioning before, and you bring them into containerized form so that essentially you can uh, reuse them, you can have them ready to be deployed. You don't have to install them on virtual machines every time, but you just pull the containers from registries and you just let them run directly. This is beautiful because it also allows for this application to scale automatically. The moment you need each component, each microservice to add more units, it's very simple to just basically run more pods of these containers and scale very, very fast. But it also ensures consistency in what is running as part of that application. So it's not that every single time you install a different version that might have a slightly different package or a different patch. Every container is prepackaged and is basically always running exactly the same way. Very easy to run long-term operations this way. Very easy to update your complete application over time and to scale it. Uh, I'm pretty sure that you've heard about operators, which are essentially the ops code around microservices. Operators essentially provide you the ability to deploy your app or your containers, to scale it. You can define with operators how many units of each app of a specific microservice you want to run, to relate it to another microservice, something which is called, some cases, glue code, um, so that, for example, a front end server can connect to a database and request a table to be created for it. And then the database understanding this relation and creating the table and offering it back. That essentially is what this relation concept, and it's done in an automated way. You don't need to code this, you don't need to script this. It is built in the operator. So bringing all these microservices together essentially helps you uh, put your complete application, your complete model of an application, and then operate it in the long run. And our approach to operators is called charms, charmed operators. It is one of the most mature operator technologies out there, and it includes features which you don't find in other operators, especially the relation concept, the glue code that I was mentioning before. Uh, Applications that are prepackaged also need to be constantly security patched because security vulnerabilities get discovered all the time. And so it's very, very important that those containers that I was mentioning before, the prepackaged containers, are constantly being released with new versions that are getting patched. And of course, having an easy way to upgrade your containers through the charmed operators. It's one of the functionalities of the operators that allows you to go back and essentially uh, update them because a newer version with security patches is released. And of course, having a true cloud native architecture with a full monitoring stack. So like an LMA stack that can monitor all these microservices, and the way that these microservices are built and are deployed and related to other microservices is truly cloud native with high availability, deployed in different availability zones, deployed uh, in a mode where if there is a failure in one of the services, your whole application is not going to be affected. Another copy can be launched automatically, and so on and so forth, even to the point where you can auto scale at the container level, and you can make it very, very easy for your application to handle increased loads. And so this essentially is what your cloud native migrated application will look like. It's containerized, it runs with operators that are secured, and of course, fully monitored with a cloud native enterprise architecture. Canonical is the supplier for all of your open source and focuses on ensuring that all of our customers are able to move to a cloud native world with packaging and distribution, support, deployment, and managed services for all of open source. So anything that has to do with open source services that you have already utilized and you need support, you need packaging, you need prepackaged containers, you need um, deployment, delivery services, architecture services, even managed services. Canonical will be that single supplier for you. When it comes to open source applications, we cover a number of apps. As you can see here, Kafka, MySQL, Postgres, Elasticsearch, and so on and so forth. All of these applications, which are typically open source, we can deploy and support for customers with one single contract. That essentially means you don't need to go to all the different companies to basically create different contracts for them. If you're interested in supported open source versions of these applications, then Canonical is the place to go. We offer deployment services where we have enterprise grade architecture and enterprise grade deployment, testing, and acceptance processes, where we can essentially deploy all the open source elements and help you also cloudify, if you will, the own code, the proprietary code of your application, so that you can easily deploy it in a hybrid cloud environment where it could be both on-prem and in public clouds, for example, or in multiple clouds because of highly availability or because of scaling or because of whatever reason. That is handled by us, especially that is handled by my team, which then leads to us offering enterprise grade support for all of those applications. 24/7, you can open support tickets to us for your Postgres database and your Kafka messaging bus, be that it's not functioning properly or it's not performing well, or you feel that there is a bug. We will troubleshoot it together with you, and we will either issue a configuration fix or we will issue a bug fix. And of course, constantly offering you security updates for all of these open source applications. And in some cases, we have customers who also are interested in us offering a managed service, for example, for a enterprise-wide messaging bus like Kafka that will be used by multiple applications. So customers tells us they would like us to offer this as a managed service, and we also offer that 24/7 with SLAs. This is a service that is specifically for those customers who want to consume those apps in a very cloud-like environment instead of actually operating them. One example is Kubeflow that we offer. Kubeflow essentially is a machine learning operations software that is made up of 30 different components, which we all provide containers for. We provide operators, charmed operators for, and can be delivered on top of any type of substrate, be that a public cloud or a private cloud, and on top of Kubernetes. A very large transportation company that is one of the worldwide ones has trusted Canonical to deliver managed infrastructure. So on the bare metal, offering bare metal as a service, then offering a private cloud or utilizing a public cloud for infrastructure as a service, and then deploying Kubernetes on top as a container as a service in multiple places, and then offering Kubeflow, Kafka, MongoDB, Postgres as applications, which are also managed or supported in some cases, that essentially are being offered so that this large transportation company can enjoy a truly cloud native experience where they've actually migrated their apps, and they can then focus on the actual innovation based on their own code instead of focusing on running these applications or getting support for these applications, and struggling with unsecured apps and struggling with very complex code that is very difficult to operate. All of these things, they work directly with Canonical, and we take care of them. And with that, I would like to thank you for listening and for spending the time, and hopefully that will be useful for you. Thank you.
Okay. Nicholas left this session. If you can come back, so maybe we can answer a couple of questions.
Absolutely.
Yeah.
I think when I pressed leave, I was thinking that I was stopping to share, but in fact, I also killed my video. But anyway, I'm here for answering any questions.
So thank you. And was interesting use case about ML ops, especially how to deploy applications using operators. And when you create such kind of operators, do you use upstream projects, or you adaptate them to your operators, and how you follow to changes in the upstream projects?
So there are two things. There is the projects themselves, and then there is the operators that operate the projects, right? Both are upstream. So both the projects themselves, as I was mentioning before, if you think about Kafka, Postgres, MySQL, MongoDB, all of these projects, we essentially take the upstream. We always contribute back to upstream every time, for example, we do a bug fix or a security update. And we package always the upstream. So we want to make sure that we always work with the upstream, and we always deliver 100% upstream of that. Then the operator side of things is also upstream. So it's also open source. And we build those operators, and others, of course, contribute to them as well. And over time, those operators grow to become even better with more complex functionality, but generally always focusing on operations like deploying, scaling, relating, upgrading, and so on and so forth.
I see. And for example, if you deploy the things like Kubeflow, I believe functions of this product also will be the same from the upstream. For example, like security management and things like this. Or we can just imagine integrate some kind of common role-based access control for ML pipeline from end to end for every product from the operators, or need to tune this on the particular product, also low-level side.
Specifically, since you're asking about Kubeflow, as Kubeflow is a collection of projects, very, very popular projects such as TensorFlow, Knative, and so forth. The security aspect of that is essentially handled through RBAC that you mentioned.
Yes.
And Kubeflow is basically taking care of this at the global level. So there's a security track or an authentication, if you will, authorization track within Kubeflow that handles it across the board. It is a multi-user service, a multi-user platform, I would call it, which is also conscious around security. But it is something that is constantly evolving, if that makes sense. If you were to compare it to other products that have been around for many, many years, I would say Kubeflow is evolving. It's not, for example, at the level of, let's call Kubernetes or a VMware, vSphere platform, which has all of these elements completely ready. Kubeflow is basically getting there, but it is in a very good track as an open source product from an RBAC approach.
And the security need to tune on inside each product, not on the macro level. Like,
well, yes. So at the end of the day, the utilization of these products is not something that you would, because you're using it through Kubeflow, you don't go and access them separately. It is handled automatically by the pipeline, if that makes sense, right? So it's not like it's not that you would go directly to TensorFlow libraries and do something. Essentially, you would be calling them through Kubeflow through your Jupyter notebooks, let's say, right?
yeah, I mean the security from operators. For example, if we combine different products, Kubeflow, database,
Right.
and Kafka Stream, etc. So different projects, and up above of these separate projects, can we use some global role-based access control, and to be sure that this data will not leave our organization, and only particular department have access to this data during the whole pipeline across different projects, or we can
I understand.
we can lose some data. So we also have GDPR like law, and company typically very think about this security and privacy.
I understand. I would say to a big extent, yes. It's not so much necessarily from the operator side. It's very much around how each product that you described implements RBAC. And in some products, it's more so. It's a difficult question to answer like that, because the question would be more about which products are implementing RBAC well, and if they do, then yes, it tends to be part of how you can configure them through operators. This is essentially one of the things that operators do. They basically have configuration parameters where basically you can say, if you want RBAC and you want this backend that is, I don't know, backed by, let's say, LDAP or something like that.
Yeah.
Yeah. Then here is the LDAP, URL that you can connect the LDAP API, for example. So this is indeed handled by the operators, as you very rightly said. And but it really depends on the products themselves. Some products are more mature in that respect, others not so much. But the operators allow for that configuration to happen, yes.
I see. Okay, I don't have questions from my side, thank you. And if anyone have questions, also can join to audio or ask in the chat. Okay, I believe we can end this session, and thank you one time again.
Thank you so much for having me. I hope this was interesting, and good luck with the rest of the day.
Yeah, thank you.
Thanks, everyone.